In today's session, I'll show you how to set up static VXLAN on Junos devices. So currently I'm demonstrating this on virtual VMX routers, but the same configuration will basically be used on QFX switches if you want to configure static VXLAN. The configuration is really pretty basic and easy to apply. So if we look at the lab, we have DC1, which consists of a single VMX, and then we have a test PC of 192.168.1.10. And we also have a data center firewall that's got internet breakout. Then moving to DC2, we have another VMX router with a test PC of 192.168.1.20 connected to this router. Then we have data center 3, which consists of a single VMX. And then also connected to it, we have test PC 192.168.1.30. So as you can see in this diagram, we have a single interconnect between each data center. So obviously on GE0 interface between data center 1 and data center 2. And then we have another interconnect between data center 2 and 3, and between data center 3 and data center 1. So just to understand, static VXLAN is basically just manual configuration. Okay, so to manage this network, you need to configure everything manually. But as I said, you will see that this configuration is pretty straightforward and easy to do. So just what you need to understand that this is not conventional layer 2. So it means that these links are rooted links. So it's kind of like routers that are connected, between them, and obviously these VXLAN tunnels will be built between loopback interfaces that exist on these devices, right? This is what they will typically call the underlay. So the underlay is a fully rooted environment between this, all these devices, and I'm using OSPF as the IGP, for link conversions if there's failure on a link. As I said, the tunnels. They are established between the loopbacks. So in your typical OSPF environment where you will have the loopbacks in OSPF as well, so that you can always have, that software interface up. Okay, so again, for this scenario, for this lab, I'm using OSPF as the IGP for root path conversions and for failover and redundancy. Okay. You can also use eBGP for that same functionality, or iSize, or whatever works for you. You will see on the typical data centers what they're doing. These days they're using eBGP for underlay and overlay. Okay. Like I said, if you manage your own, small data center or enterprise data center, you can use OSPF, whatever you have available. Okay. So as I said, in this lab we have OSPF running as the IGP between these entities. All right. Let's go to device 1. All right, so as you can see here, we have OSPF up between 1.2 and 1.3. And let me just move this a bit. So as you can see, on interface 0 and interface 1, 0 and 1, we have OSPF up. And then if we go to data center 2, show OSPF neighbors, same thing, OSPF is up. Remember, you can look, if you want to know how to set up OSPF, on Junos devices, there is a video which you can just follow, and it will show you how to set that up. So that's why I'm not going to go into that part. This is already operational. OSPF is already operational in this lab. So let's just confirm our IGP is up. All right, so as you can see, everything is, OSPF is up at the moment. Let's quickly go to a test PC. Let's go to this test PC. So what I want to do is I just want to do a ping towards, let's say, .20. So as you can see, there's no pings. Host unreachable. And if we go to DC1, if I do a show bridge MAC table, as you can see, there's no MACs. All right. So if we look at the current MAC table, well, obviously there are MACs, but we're not seeing any remote MACs. So this is a locally learned MAC address on interface 3. That's towards PT1. And this is a MAC address that's learned on interface 4 towards the firewall. But as you can see, there's no other remote MACs that it's basically learning. Yeah. So let's quickly just look at the configuration. So I've already configured, I've already done the configuration on DC1. And then we'll move to DC2 and DC3, and we'll do the configuration on those. All right, so let's quickly just have a look at how the configuration looks like. So I'm going to go into configure, edit interfaces. So let's see what we have. All right, so as you can see, these are just the point-to-point routed interfaces between the data centers, that interconnect where the OSPF is running across. Then I have GE port 3 that is connected towards PC1 and interface mode access in VLAN 10. Okay. And then obviously we have interface 4, which also operates in VLAN 10. And then we have our loopback address, which is very important in this scenario, and obviously it needs to be unique. Okay. Then if you go to top edit, switch options, you do a show. What we have here we have the statement VTEP source interface loopback. So it means when this builds a VXLAN tunnel to wherever it needs to build it to, let's say if it sources a tunnel from this loopback towards this 2.2.2 or 3.3.3, it needs to use the loopback interface. Okay. So you need minimum configuration, you need that statement. And obviously the remote VTEP list. So these are the loopback IP addresses of the remote devices where the tunnels should establish to. So 222 in this case is data center 2 and 333 is data center 3. Okay. Then we go to top edit bridge domain. So on your QFX switches, this will be under the VLAN statement. Let's do a show. Here we have VLAN 10 with a VLAN ID of 10. Then we have the VXLAN VNI value. And then we have ingress node replication. So this is the minimum configuration that you need to configure static VXLAN. Right, so let's just go to the top. I'm going to go to exit. Right, so let's go to data center 2. All right, let's go configure, edit interfaces, show. All right, so as you can see here, currently I've configured a loopback of 2222, but interface 3 towards PC2 is not configured yet. And then if we go to top edit switch options, we do a show, no switch options, top edit bridge domains, no bridge domain. Okay, so let's configure VXLAN quickly. So let's start with switch options. Edit switch options, show. So remember that statement, set VTEP source interface, the loopback. Okay, set remote VTEP list, set remote VTEP list. All right, so this is the loopback then of DC1, and this is the loopback of DC3. Do a show. Okay, good. Top edit bridge domains, show. So we want to configure, so we're going to use VLAN 10 as, the VLAN we're going to demonstrate, this lab in. So set, let's already just do edit VLAN 10. And we're going to say set VLAN ID 10, set VXLAN VN 110. So this value needs to be unique in this VLAN. So it needs to be the same value as anywhere in the data center for this particular VLAN. So this is very important. Make sure that this VLAN is unique across your data center. All right. So let's see what else we need. Okay, set. Okay. Then we go to top edit interfaces GE003. So obviously we want to put PC2 now in this VLAN. So we say set unit 0 family bridge interface mode, access interface, VLAN ID 10. Okay. All Right, so let's quickly just look at, let's do a show pipe display set. Maybe that will show us. All right, so as you can see, we have VLAN 3 now configured in VLAN 10 as an access port. We have our loopback address. We've got bridge domains for VLAN 10, VLAN ID 10, and we've got VNI 110, and then we have the switch options. We have VTEP source interface to loopback, and then we have our destination nodes where the tunnels can form to. So if we do the same configuration output here, so configure, and we do a show pipe display set. Okay, so let's just compare what we have here. So interface 3, VLAN 10, interface mode access, unique loopback. We have VLAN 10, 110 for the VNI, loopback, remote. Okay, so let's commit that. Okay, so let's go back to PC1 and let's see if we can actually now source towards 1.20. All right, so as you can see, we're seeing a ping there. So let's go capture Ethernet interface 0 on the test PC, and let's see what we see. Let me just go back to PC1 again. Let's do a ping -T. Alrighty. As you can see, that ICMP is now getting across. So let's stop that ping there, and then we stop this here. So let's see what we see. All right, so obviously these packets, as you can see here, currently is uncapsulated. So this is already or decapsulated. I don't know what's the right word, but anyway, so this traffic is not inside the tunnel anymore. So let's relaunch this ping again. We're going to close this window. And let's now capture on interface GE000, or port 0. So we should see that same traffic, going across this link, but it should be encapsulated in the VXLAN packet. So let's stop that, and let's see, we've got a source from 1.10. So as you can see, and now we've got VXLAN encapsulation that's happening. So remember that unique, VN value that you had to create on the, the VLAN statement. So here you can see it's using that particular value as an identifier, obviously, to see where, if I receive a packet with this value, where does it need to go? All right, so now it can map this value to a configured VLAN, and then it knows where to send that to. All right, so as you can see here, this is still encapsulated in VXLAN. Same source, same destination, same protocol, ICMP. Now let's go to DC3. So what we want to do is we want to enable DC3 for VXLAN as well. So let's see what we have here. So if we do show OSPF neighbor, so OSPF is up, configure, edit, switch options. So what do we have? Nothing at the moment. So it's set, VTEP source interface LO0.0, set remote VTEP list. Okay, remote VTEP list, loopback of DC1 and loopback of DC2, and commit that. Configure, edit bridge domains, show. All right, set, let's do it. Edit VLAN 10, set VLAN ID 10, VXLAN, VNI. Remember, this needs to be unique for this VLAN. Okay, so that should be that configuration. And then we go to top edit interfaces, GE003. And we want to set unit 0 family bridge interface mode, access VLAN ID 10. Commit and quit. All right, show pipe display set. All right, so let's just see if our configuration is correct. So we have interface 3, access port in VLAN 10, unique loopback IP address. We have the bridge domain specified with the VNI value, switch options configured with loopback, source, and then the remote nodes. All right, so that looks like all the configuration we need. Let's close that. So now if we go to PC3, let's go to PC1 quickly. So and if we do a ping towards 1.30 now, we should be able to ping it as well. And we can go to Wireshark. All right, so as you can see, here we have a sort from 1.10 to 1.30. Okay, cool. And then let's go to PC2. So again, PC2 should be able to ping 1.30 as well. So here you can see you can ping 1.10, 1.30. So as you can see, we have full communications between all three of these devices. So if we go to, let's go to DC1 quickly. Let's just go X configuration, do a show bridge map table. Here we can see now we've got our locally learned MAC address towards PC1, the local test PC. That's towards the firewall. And then we have the remote MAC addresses for the remote PCs, learned via the VTEP tunnel. So what I'm going to do is I want to set up a gateway or an internet gateway via the firewalls for all of these PCs as well. So what I want to do here is I'm going to set up VRP between these two firewalls. So we'll have VRP running across these two firewalls, and I'll make one master and one backup. Then we'll do just kind of like a failover on one firewall. Then we can also do a link failover. See that we can now switch traffic still towards the other data centers, even if there's a link failure. All right. So just remember that this environment is obviously virtual, so I can't physically unplug the interface. So it's probably going to take some time for the failovers to happen because the timers needs to expire, right? So where in some environments where you unplug the interface, your protocol will instantaneously just reconverge onto the next part. So just keep that in mind. But essentially, the goal is for the failover to still work, all right? Even though it might take a little bit longer. All right. So let's go to FortiGate 1. So if we look at the lab, you will see that we have interface 1 connected to interface 4. And then the same on that side. And then we have interface or port 2 connected to the internet. So we'll configure that accordingly. All right, so let's go to FortiGate firewall 1. Let's go and configure the interfaces. So as I said, port 1, it's towards the the data center. And I'm going to configure it with 192.168.1.2/24. So okay. Let's just look at the static routes quickly. So as you can see, currently the routes that we have is a default route. So if we just go back to the interfaces quickly, so you'll see that port 2 towards the internet, it's got IP address of 1084.0.200 configured. So that is an external interface towards the internet. Well, let's just say to the lab internet. That's the external interface to the lab internet. And then obviously, if we look at the static route, we have a default route to 84.0.1 out port 2. Okay. Then if we go to FortiGate Firewall 2, so we look at the interfaces that's currently configured. So as you can see, port 2 is configured with 84.0.201. And if we look at the static route, default route to the same gateway out of port 2. So let's configure the inside interface towards the data center, and we want to configure that as 192.168.1.3/24. Okay, so 1.3 for DC2 firewall and 1.2 for DC1 firewall. So obviously, we'll be configuring a VRP between these two firewalls, and then we can also simulate that you can run VRP across the VXLAN tunnels, like conventional VLANs, as you would do with conventional VLANs. All right, so let me go to DC Firewall 1. config system interfaces port 1 show. All right, so what we want to do is we want to configure the VRP, so let's quickly do that. Let's set VRP enable, then config VRP. Let me say set version, edit 1, then set version 2, set VRG group, we're just going to call it 10, set the virtual IP, so it's going to be 192.168.1.1, set priority, so this is firewall 1, so I want it to be the master, so we're going to give it priority of, let's say, 100, and set status enable, and then we're going to say end, and we do a show, and here you can see we have virtual Mac enabled here, and here is the VRP config. So let's go and do the same on firewall 2. Config system interfaces edit port 1. Yeah. Let's do a show quickly. All right, so we go set VRP virtual Mac enable config VRP edit 1 set VRG group 10 set the virtual IP 192.168.1.1 and set priority. I'm gonna give it priority of 50 and then set status enable. Do a show full configuration. So here you can see we have, this is the configuration that we currently have configured on there. So let's say go to end, and we say end, and then end. So I think that should be the minimum config that we need. So if we go to get router info VRP, so the state, so here we can see this is the virtual router IP of 1.1, and it's got a state of master. So let's do the same here as well. Get router info VRP. All right, so same virtual IP of 1.1, and then we have the state of backup. Okay, so great, so that's what we want. So if we now go to test PC 1 and we do a ping, we can ping that. All right, let's do a ping towards 8.8.8. So as you can see, it's not pinging it. So obviously we need to add a security policy. So considering that DC1 firewall is the active one, so let's go and add that policy in there quickly. So let's quickly build a policy. We can just create a new policy and call it internet incoming interface. So from port 1 towards port 2. So we're just gonna create a any policy or all policy, all service, and we want to do a NAT. Okay. All right, so let's see if we are getting pings. All right, so as you can see, we're getting pings now towards the internet. All right, so let's just go and enable the same policy on the other FortiGate as well. So incoming port from port 1, outgoing port 2, all servers, and we want to do a NAT. I'm going to say okay. All right, so now we've got the same policy configured on firewall 2 as well. So that means should the VRP fail over, or this DC2 firewall becomes master, then the traffic should still be able to reach the internet. Let's see if that happens. So what we're going to do is let's quickly just go to the test PC still. All right, so we're running that test now. So let's go to firewall 1. This is firewall 1. So let's quickly just go to the CLI. I want to do a, what's that? Diagnose sniffer packet port 1. All right, so as you can see, so we're kind of like doing a real-time Wireshark capture on the firewall. So as you can see, this is the the ICMP or the pings that originate from 1.10 towards 888. So if we do the same thing on DC firewall 2, diagnose sniffer packet port 1. So as you can see, we only have the VRP, that's happening between the interfaces. So there's nothing going towards, towards the internet via this firewall. So let's stop it there. All right, so we have the ping running here. I'm going to go to DC firewall 1 and reboot it. Let's keep the reboot, and we're going to say yes. So the system is rebooting now, DC 1. So if we go to this firewall and we do a get router info VRP, as you can see, it's master. And then if we do that diagnose sniffer packet on port 1, here you can see that ping is now going out this firewall. All right, so as you can see now we have a VRP running between 2 nodes, firewall nodes, on a VXLAN environment. So we know that's working pretty good. All right, so let's just wait for firewall 1 to come back online. What we can do is we can maybe do some failovers between different PCs. Let's quickly let's stop this ping test here. And then I'm going to do a ping towards 1.20. So if we go to DC1 and we do a show root, let's just do a show root 2.2.2. All right. So essentially what we want to see is what is the shortest path towards 2.2.2. So obviously 1.20 is the test PC in DC2. And the VXLAN tunnels, if a VXLAN tunnel is built across DC1 and DC2, it will follow this path. Okay, so there's no equal cost multipath configured in this lab. It can also be configured if you want that enabled. But for now, it's just using the shortest path based on the OSPF between the loopbacks. So essentially what I want to do is I'm going to go to DC2. I'm going to go set interface GE000 disable. Okay. So what I want to do is I want to disable this interface and bring down OSPF. So as I said, remember this is a virtual environment, so it might take a while for OSPF to time out here and then take the other part. Let's do that quickly. All right, so we have DC2. Let's do a show OSPF. Show OSPF neighbor. And then we have this ping running as well. And then on DC2, I have that interface disabled, but let me commit it. Let's wait for this to time out. So if we do a show root, so as you can see, it already took the path via GE001. So yeah, you didn't even see any drops in there. So that was pretty quick. So let's do that same thing. Let's run this ping again. And we do a rollback 1, show pipe compare. So I'll be restoring this interface again. So let's just do a show OSPF neighbor. So as you can see, OSPF is now still off. So let's do a rollback and we commit that. All right, so it's back on show root. And as you can see, it's taking that path again. And I don't even know if there was any packet loss. All right, so that was actually pretty quick. So that basically demonstrates how easier it is to set up a static VXLAN. Even if you have to compare this with conventional layer 2, the problems that we'll run into is when you have, when you have a single link between two data centers, it's fine. Or if you have two and you put it in an AE interface, then you're fine. You won't have any loops. But the challenge just comes in is when you introduce a third data center, and you want to have this kind of ring topology. So if you're using conventional layer 2, you're going to run into issues with loops. All right. So this is a pretty good alternative to use static VXLAN instead of conventional layer 2. And as you've seen, if you configure a VLAN, you just need to configure it under the VLAN interface statements, and you don't need to go and obviously tag it on a trunk interface, do all that. So it's just a matter of going under edit VLANs, configure VLAN, your VNI, unique label value, commit it on here, commit it on the remote node, and your VLAN is extended. You don't need to worry about tagging upstream trunk interfaces and all that. And as I've shown in this lab as well, typical data center deployment with a active and passive firewall. So if you experience failure on a particular firewall, the VXLAN, you can still use VXLAN to extend your VRP. Obviously, if you have link failures, same thing. OSPF will take care of that. Your tunnels will just, or your traffic will just reconverge over the other links. Thanks for watching. Hope you enjoyed this video. If you did, hit that like button, hit that subscribe button, and hope to see you in the next one. Cheers.